Hello everyone, and welcome back to the channel. Today we're going to be going through trigonometry, okay, and the full guide of trigonometry, specifically part 1. Okay, so in this episode we're going to be going through the majority of the theory that you'll need for trigonometry in Pure 3, and then in the episode after we'll go through some more concrete exam style examples. But this is necessary because this gives you a foundation to work off. Okay, so we're going to be going through the compound angle formulas and all the other identities you'll need, and just simply how to kind of approach different questions. If you find value in this content, guys, make sure to like, subscribe, obviously put the notification bell on as well. It really helps the channel out, and yeah, of course, share as well. If there's anyone who needs help with this, share it in your WhatsApp groups, share it with your class, and without further ado, let's get right into it. Alright guys, so the first thing we're going to be looking at here are inverse functions, okay? Specifically, the inverse functions when it comes to trigonometry. So our first one here, okay, and this is important, is 1 over sine x, okay? Which we can call cosec of x, okay? Now, again, this is all theory, so it's not really as necessary to know all the specific points and details. The key thing you need to know from a practical standpoint, okay, is that just like sine of x, the period here is going to equal 2 pi, okay, meaning that it repeats itself every 2 pi iterations, okay. So as you can see, negative 2 pi over to 2 pi here, we've got a full. So over here, 0 to 2 pi, we've got a full kind of iteration there, right? And so that's basically it for cosec of x, okay? It's simply the inverse of sine x, okay? And that's the key thing you need to know for now. Obviously when x equals pi over 2, y equals 1, and you can see the different points here, okay, with the ranges between negative 1 and 1 again. Alright guys, so now we've got the inverse of 1 over cos x. Okay, now what does this equal? Well, 1 over cos x, okay, simply equals sec x. Okay, it equals sec x. And this is a very important one, okay, because this comes up a lot, particularly in your different identities and whatnot, so it's very important. And the key thing about sec x, okay, just from a graphing perspective, is again the period is equal to 2 pi. Okay? The period is equal to 2 pi. And you can see that. You can see that. Okay, we've got iteration here. Okay, we've got iteration here. Okay? And of course the range okay, it's negative 1 to 1. Okay, as you can see, negative 1 to 1. Alright guys, now 1 over tan x. Okay, 1 over tan x is the same thing as saying cot x. Okay, it's the function cot x. And similar to tan x, cot x has a period pi. Okay, it repeats itself every pi times. Alright. Okay, and you can see that in the graph here. Okay, so the 2 pi, okay, repeats itself every pi times. And so, also, what's important here is, as you can see, we never ever get a situation where we get a capped range, okay, or capped y value, and as a result we've got asymptotes. Okay, we have asymptotes that the function tends towards. So as a result, the range is going to equal negative infinity to infinity. Okay, so that's it for the graphs. Not too much to go into detail because it's not as necessary from a practical perspective when actually writing the exam, but it's just good to have this as context. Alright, so now we move on to trig identities. Okay, now this is extremely important. Okay, now as I said in the beginning, this video is going to be very much a foundational video for basically teeing up the content in the next, which is going to be a lot more practical. But here, we've got some very key important things to recognize. Okay, so here we've got the trig identity. Cos squared theta plus sine squared theta is equal to 1. Okay, we know that from the beginning. Okay, that's from AS. Now, this is also true. 1 plus tan squared is equal to sec squared theta. Okay, that's another trigonometric identity that's extremely important. But how do we get there? The way we get there is by dividing by cos squared theta. Okay. If we divide by cos squared theta, what we get is 1. Okay. Plus sine squared theta over cos squared theta is equal to 1 over cos squared theta. And obviously, that therefore, okay, it's going to equal 1 plus tan squared theta is equal to sec squared theta. Why? Because 1 over cos squared theta is equal to sec squared theta, okay, as you just saw in the graphs, and sine squared theta over cos squared theta is equal to tan squared theta. Alright, so now we've got the following. We've got 1 plus cot squared theta is equal to cosec squared theta as an identity. And this is obviously derived from this. So how does that work? Well, in this scenario, what we've done is we're going to divide by sine squared theta. Okay? Because if we divide by sine squared theta now, what we get is cos squared over sine squared theta plus sine squared theta over sine squared theta is equal to 1 over sine squared theta. Okay? Now you'll remember, okay, that sine squared theta over cos squared theta is equal to tan squared theta. So if you flip this, okay, where you get cos squared theta over sine squared theta, that's going to equal 1 over tan squared theta, which is going to equal to cot. Okay. Meanwhile, that's going to equal 1. And then here we've got 1 over sine squared theta, which equals cosec squared theta. So therefore, what we get is 1. If we're doing it this way, we can do it's going to equal cot squared theta plus 1. Okay, is equal to cosec squared theta. Okay, which obviously rearranges to be exactly the same here. Okay. Now this group of identities, okay, it's not as important to derive or whatever, but you just need to kind of know it, and you'll feel it intuitively. It's based off how things look on the graph, but I'm not going to go into detail on that. Okay, this is a lot more of a practical course. The key thing here is basically that whenever you've got tan or sine and their inverses, okay, if you've got a negative theta in as the input, it's going to equal negative the output. Okay, so it's going to equal negative of the function. Okay, so negative theta, you can take out the negative here. On the other hand, if you've got cos of negative theta, right, we can just get rid of the negative altogether and just say that's equal to positive cos theta. Okay, and obviously sec is the inverse of cos. Okay, so we can say the same thing over here as well. Okay, just to recap that, negative theta, negative tan theta, Okay, negative theta, negative sine theta, negative theta plus cos theta. Alright, so the next group of identities that are going to be necessary for you to be familiar with are what's called the compound angle identities. Okay? And it's, for instance, when you've got something like cos a plus b, or cos a minus b, or sine a plus b, or sine a minus b, which we'll get into in a second. Okay? And it's key to just understand that this is what it equates to. Okay, and you'll have this on your formula sheet. So, let's imagine we've got a question that says, find cos of 5 pi over 4 minus pi over 6. Okay, how do we go about doing that? Okay, and let's imagine that they want us to show our working in full. Okay, so what we can say is, alright, cos 5 pi over 4 minus pi over 6 is going to equal cos of 5 pi over 4 cos of pi over 6 plus sine 5 pi over 4 sine of pi over 6. Okay, now why has that happened? Because cos alpha, cos beta, okay, beta. And this obviously equates here as well. Alright. So now we can just say, well, if we're showing all our working, that's just going to equate to negative root 2 over 2, okay, times root 3 over 2 minus root 2 over 2 times a half. Okay, because all we've done is we've equated each of these accordingly. And from here, we can say, fine, well, all we're going to get now is negative root 6 over 4, okay, minus root 2 over 4, which equals negative root 6 minus root 2 over 4. Okay? And that's going to be the final answer there. So this is not complicated. It's not something you need to get in the exam, but it just demonstrates this identity well. Okay? We've expanded, we've subbed in, and we've simplified. Alright, so now, okay, we've got the sine variant of this, okay? So the sine variant of this is sine alpha plus beta. It's equal to sine alpha cos beta plus cos alpha sine beta, okay? Similar to concept, but it's different, obviously, from what you saw before. And if we have the equation like this, how do we expand it? Okay, so sine 45 degrees minus 30 degrees can be expanded, okay, according to this formula. Okay, if we expand to that formula, what do we get? It's sine 45 degrees times cos of 30 degrees minus cos of 45 degrees times sine of 30 degrees. Okay? So we've expanded again according to this formula. So what do we say? Well, we know that sine of 45 degrees is equal to root 2 over 2. We know that cos of 30 degrees is equal to root 3 over 2. We know that cos of 45 degrees is equal to root 2 over 2. We know that sine of 30 degrees is equal to a half, right? Perfect. We've got what we need now. We just need to substitute in. So if we substitute in, okay, what we get is the following. We're going to get root 2 over 2, okay, times root 3 over 2 minus root 2 over 2 times a half, which is going to give me what? It's going to give me root 6 minus root 2 over 4. Okay, and that's going to be the final answer. Again, just an illustration, but it's important just to realize how this kind of works and how you go about doing this. It's simply a case of plugging in what we need, simplifying, and getting the answer. Alright guys, now another very important key set of trigonometric identities that you'll come across are these. Okay, now I've skipped a bit of the legwork here because, again, I want to really get into the practicalities of it that's going to serve you later on. But as you can see, it's a case of saying, well, sine 2 theta is equal to 2 sine theta cos theta. That's our first one. Our second one is cos 2 theta is equal to cos squared theta minus sine squared theta. Obviously, these ones follow. Okay. These ones follow. And then we've got tan 2 theta is equal to this. Right. So, a common kind of scenario that will occur is when you need to convert something like this. Okay. You're going to need to expand this, whether it's in an equation, whether it's in a identity, what have you. So this is an important skill. If we need to expand this, we can say that cos 6x, alright, is the same thing as saying cos of 2 times 3x, no? Now what does that look like? What does that look like here? What that looks like is 2 theta. Okay, sorry, over here. Okay, cos 2 theta. Okay, which means we now have leverage to expand into these equations. Alright? And so what we can say is this simply equals 1, okay, let's do this, 2 cos squared 3x minus 1. Okay, it's like magic, because as you can see, we've expanded from this into something we can solve for. Okay, which is going to be critical as you get into the equations parts of this syllabus. Okay, so here's an example, and the next few examples are going to be like this as well, where basically they want us to verify an identity, okay, trigonometric identity, i.e. the left-hand side is equal to right-hand side. Now, the way to think about this, okay, is that these ones are going to show are relatively straightforward, but they illustrate a point, and these are going to be the foundational blocks that you'll need to answer more harder type questions, okay? So, if we look at this, right, what can we say? Well, what I'm going to do is I'm going to go to the right-hand side, okay? Right-hand side, so sine theta plus cos theta squared is equal to sine squared theta plus 2 sine theta cos theta plus cos squared theta, okay? Now, what does this show you? Well, what is sine squared theta? Okay, what is sine squared theta when combined with plus cos squared theta? Okay, we can say that we get sine squared theta plus cos squared theta plus 2 sine theta cos theta here, which means we get 1, okay, plus 2 sine theta cos theta. And where did you see this before? Well, this, if we scroll up, looks similar to this, doesn't it? Okay, so therefore what we get is 1 plus 2 theta. Okay, so therefore we can say left hand side is equivocal to right hand side. Well, better yet, I should say right hand side. Usually it's left hand side in the exam or whatever. Right hand side is equivocal to left hand side as required. Alright, so in this example, we've got the equation that says the identity that says verify tan 2 theta is equal to 2 over cot theta minus tan theta, right? So, how do we go about doing this? What I'm going to pick first is I'm going to say left hand side, okay? Because the left hand side looks like something we can work with in a lot greater ease compared to the right hand side, okay? So what I'm going to say is tan 2 theta is going to equal what? Now if we go back up, tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Okay, so tan 2 theta is equal to 2 tan theta over 1 minus tan squared theta. Right? Brilliant. Brilliant. So where can we go from here? Where can we go from here? Remember what we need to get to. We need to get to 2 over cot theta minus tan theta. Right? And we need somehow to get this, okay, as our denominator. Cot theta minus tan theta. So, and at the same time, of course, we need to get rid of this tan theta here. So how do we go about doing that? So what we can say is that this is going to equal 2 tan theta times 1 over tan theta over 1 minus tan squared theta times 1 over tan theta. Okay, now why is this? This is true because all we've done is we've multiplied by 1. Okay, remember that this over this is 1, right? We've multiplied by 1. But tan theta, this is going to rule out, okay, to get us to 2, which we want, okay? Because tan theta is going to go in the numerator. So that's what we've done, but obviously you need to times by the denominator as well. So moving forward, let's expand this out. So we get then 2 over, let's see, 1 minus tan squared theta over tan theta. Okay, which if we keep going, we get 1. Remember, because it's 1 denominator here. 1 over tan theta minus tan squared theta over tan theta, which equates to what? 2 over cot theta, okay, because 1 over tan theta minus tan theta. Okay, and what do you know? This is the same thing as this. So therefore I can say the left hand side is equivalent to the right hand side as required. Okay, so let's look at that again. You want to verify this. We've got tan 2 theta, okay, we used identity here. We then multiplied it, okay, we rationalized it with 1 over tan theta over 1 over tan theta, okay, to get here and here. Okay, 1 over tan theta minus tan squared over tan theta to get to this. So therefore left hand side is equivalent to the right hand side. Okay, going into more groundwork here, we've got the reduction formulas. So the first one is sine squared theta is equal to 1 minus cos 2 theta over 2. Okay, the way we get this is by saying this. Okay, remember that cos 2 theta is equal to 1 minus 2 sine squared theta. Okay, therefore we can say that we're going to get 1 minus cos 2 theta equaling to sine squared theta, which means that sine squared theta is equal to a half 1 minus cos 2 theta, okay, which equals this. Pretty simple. It's just a way to show how this works. Okay, and the same thing can be said here. Okay, cos squared theta is equal to 1 plus cos 2 theta over 2. Okay, remember cos 2 theta is equal to 2 cos squared theta minus 1. Okay, which means that 1 plus cos 2 theta is equal to 2 cos squared theta, which means that 1 plus cos brilliant. Okay, and lastly we've got this one. Okay, so tan squared theta over 1 minus cos 2 theta over 1 plus cos 2 theta. So this one's a little bit more interesting. Okay, because you've got to remember that tan squared theta is equal to sine squared theta over cos squared theta to begin with, which means what? Okay, which means if we go up, we can plug in, because we've got formulas for both. We've got cos squared theta, which can plug in here. We've got sine squared theta, okay, which can be plugged in over here. So therefore what we get, okay, is tan squared theta is therefore going to equal 1 minus cos 2 theta over 2 over 1 plus cos 2 theta over 2. Okay, so as you can see, we've got these two here. Okay, so that's just a case of simplifying this out. What that's going to equal is 1 minus cos 2 theta over 2. Okay, and that's going to be multiplied by 2 over 1 plus cos 2 theta, which equals 1 minus cos 2 theta over 1 plus cos 2 theta. Okay, so a little bit more boring, but it's just a quick, just quickly deriving where these equations actually come from. Okay, and that's all this is. Alright guys, so now we've got a example where it wants us to write an equivalent expression, okay, for cos to the power 4x that does not involve any powers of sine or cosine greater than 1. In essence, it wants us to break down cos of 4x, okay, cos to the power 4x, into its bare bones. Now the key thing here is that, remember, this is not going to be something they're going to ask in the exam. However, it's a skill that's very useful, because when you're going through certain papers or certain questions, breaking, the powers down is going to be very useful. So this is what I'm doing here. We're building the foundations, right? So cos to the power 4x equals what? break it down. It's cos squared x squared, right? Now what is cos squared x? Okay, cos squared x is equal to 1 plus cos 2x over 2 squared, right? Brilliant. Now let's expand this out even further, right? Because what we can do is this is equal to 1 plus cos 2x squared over 4, right? Which gives me what? We've got a quarter of 1 plus cos 2x squared, which gives me a quarter of 1 plus 2 cos 2x plus cos squared 2x, right? Fantastic. Fantastic. So, what's this going to give us then? Well, we get a quarter then of, let me see. If we expand this out, we just get a quarter. Okay, plus a half cos 2x plus a quarter, okay, of cos 2x squared, okay, which equals, again, a quarter plus a half cos 2x, okay, plus a quarter of 1 plus cos, okay, 2 times 2x over 2. Now let's look into this a little bit. Where is this coming from? Okay, well, remember what cos squared x is equal to. It's equal to this. Okay, cos squared theta is equal to this. 1 plus cos 2 theta over 2. Okay, so if you just pretend this is theta, it's like saying 1 plus cos 2 theta over 2. Okay, but our theta is 2x, which is why we've plugged in. Okay, so this is where this is coming from. Right, so we can expand this out even further now. We can say that we've got a quarter plus half cos 2x, okay, and if we expand this out, we get an eighth plus an eighth of cos 4x, okay, which means if we just simplify now, we get 3 over 8 plus a half cos 2x, okay, plus an eighth of cos 4x. Recapping this, remember we plugged in here, okay, which concurs with this, alright, and we also obviously just broke down in the beginning, okay, with cos 2x, okay, to eventually get here. Right, so next formula group here is the product of sum formulas. Okay, now these identities they don't crop up as much, but they're still there, and it's still important to know because they're going to come up in those harder type questions where they're really trying to test you. Okay, so I'm not going to read these out because it's pretty simple to see, and you'll have them on your equation booklet. But let's get into some examples to see exactly how they work in practice. Okay, so over here it says write cos 3 theta times cos 5 theta as a sum or difference. So how do we go about doing this? Well, let's go up. Okay. Cos alpha, cos beta. That's what we've got here. Okay. So we're going to apply this, shove it here. Okay. And when we do that, what we get is the following. Okay, so remember cos alpha, cos beta is equal to a half of cos alpha minus beta plus cos alpha plus beta. Okay, so therefore cos 3 theta cos 5 theta is equal to a half. Okay, cos 3 theta minus 5 theta plus cos 3 theta cos 5 theta. Brilliant. Brilliant. So what do we get? Well, that's going to give us cos minus 2 theta plus cos of 8 theta. This looks a bit weird though, doesn't it? If you remember, what is cos of negative theta equal to? Well, it's just equal to cos theta. And so this is going to be equal to cos a half cos 2 theta plus cos of 8 theta. Okay, and this is going to be your final answer. Alright, so here we've got the inverse scenario. Here we've got sum to product. Okay, it's basically the inverse of the other equations. Well, actually not quite, but just don't get them mixed up. Okay, basically we've got sine alpha, sine beta. Okay, these are very useful to know. I think I might put them in the equation booklet now. If not, make sure to remember these, because these do come in useful, particularly if you want to work quickly. Okay, and without further ado, let's get into an example, because that's the best way to show how they work. Right, so here we've got sine 4 theta minus sine 2 theta, right? So this is sine alpha minus sine beta. Sine alpha minus sine beta. It's over here. Okay. What's that going to give us? Well, sine 4 theta minus sine 2 theta. Okay, equals what then? Well, 2 sine 4 theta minus 2 theta over 2 times cos of 4 theta plus 2 theta over 2. Why is that the case? Because remember, sine alpha minus sine beta, we're equating here, okay? Just plug this in. So therefore, what we get is 2 sine 2 theta over 2 times cosine of 6 theta over 2, which gives us 2 sine theta cos 3 theta. Okay, this is just a quick example. Don't overthink these ones. Okay, and indeed the previous set of identities, the product of sum. Okay, don't overthink it. Okay, don't overthink it. You just need to know how to plug in, okay, and when to use it. That's all the important thing is. This is just an example of how to plug in, okay, but it's more of a complement to the question rather than the question itself. Alright guys, so now we've got a bit more of a realistic example, okay, where you'll be asked to prove an identity. So let's look at this. We've got cos 4t minus cos 2t over sine 4t plus sine 2t is equal to negative tan t. Okay, so we have to decide now which side is going to give us the next one, right? And expanding negative tan t to get to this is going to be very difficult. It's not impossible. But getting from here to here looks a little bit more manageable. So let's start with left hand side. Okay, so here's what I can say. Cos 4t minus cos 2t sine 4t plus sine 2t equals what? Well, let's use our sum to product formula here. Okay, so cos alpha minus cos beta over here, right? So what do we get? Minus 2 sine 4t plus 2t over 2 times sine of 4t minus 2t over 2. And that's going to be over 2 sine 4t plus 2t over 2 times cos of 4t minus 2t over 2. Okay, brilliant. So we've got this here, which means what? Let's break it down. So if we break this down, we get negative 2 sine of 6t over 2, which equals sine of 3t. And then 2t over 2, that's just t. Okay, sine 3t, sine t. Okay, and then we got 2 sine 3t over cos t. Okay, and what do you know? These are going to cancel. Okay, which means we therefore get negative sine t over cos t, which equals to negative tan t. Okay, so therefore left hand side is equivocal to right hand side as required. Okay, that's the final answer. This is a great example of using the sum to product formula. Okay, we've simplified it so much more, and eventually we were able to get to negative tan t as required. Alright guys, now the last identity we're going to verify before we get into a video that's going to be a lot harder with a lot more realistic examples is cosec squared theta minus 2 is equal to cos 2 theta over sine squared theta. Okay, so here we can say this. Okay, if we approach this from the right hand side, what we get is cos 2 theta over sine squared theta is equal to what? Okay, well, cos 2 theta is equal to 1 minus 2 sine squared theta over sine squared theta. We break this down further. 1 over sine squared theta minus 2 over sine squared theta over sine squared theta. Okay, which equals cosec squared theta minus 2. Okay, now obviously this is quite a simple example. Okay, and remember that a lot of these examples were quite simple, but it's all about building that foundation, because when we get into the next video, we're going to be going through some more harder equations and different types of identities that are a little bit more challenging. So if you enjoyed the video guys, make sure to like, subscribe, comment, and I'll see you in the next